Hi friends, welcome back to our digital VLSI channel. I hope you guys are doing well. In our previous video, we have completed the 4x1 multiplexer. Today I am going to discuss about 8x1 multiplexer, which is similar to the 4x1 multiplexer but with some slight modifications. Let's dive in and see how it works. So 8x1 multiplexer we can simply call as MUX, and it is a combinational logic circuit that selects one of several input signals and forward it to a single output. And this is a black diagram of 8x1 multiplexer where I0 to I7 are called input lines, S0, S1, S2 are called selection lines, and it has only one single output, that is Y. Usually for n selection inputs, there are 2 power n input lines. Here n is equal to 3. So 2 cube is equal to 8 input lines. These control signals S0, S1, S2 controls the input signal selection. And this is a truth table of 8x1 multiplexer. Here we have 3 selection inputs, so 8 possible combinations we will get. For S0, S1, S2 is equal to 0, 0, 0. I0 is connected to the output. S0, S1, S2 is equal to 0, 0, 1. I1 is connected to the output. Similarly, S0, S1, S2 is equal to 1, 1, 1. I7 is connected to the output. Now let's write the logical expression. So Y is equal to S0 bar, S1 bar, S2 bar into I0 plus S0 bar, S1 bar, S2 into I1 plus S0 bar, S1, S2 bar into I2, S0 bar, S1, S2 into I3 plus S0, S1 bar, S2 bar into I4 plus S0, S1 bar, S2 into I5 plus S0, S1, S2 bar into I6 plus S0, S1, S2 into I7. This is the logical expression. Now let's draw the hardware circuit. And this is the final hardware circuit for the 8x1 multiplexer. Here S2, S1, S0 are the selection inputs and I0 to I7 are the input lines. Here S2 bar, S1 bar, S0 bar and I0 is connected to one AND gate, and similarly S2, S1, S0 and I7 is connected to another AND gate, and all these multiplication terms are added with the help of OR gate. Here OR gate output is the final output. Yeah, that's it about 8x1 multiplexer. I hope now you guys have a clear understanding of 8x1 multiplexer. Similarly, you can implement 16x1 and 32x1 multiplexers. Now I'm going to show you how to write Verilog code for 8x1 multiplexer. First, let's start with module. Some name mux underscore 8x1. And then now we need to declare inputs and outputs. So input 7 down to 0, I. Instead of writing I0, I1, I2 till I7, I'm writing in the form of vector 7 down to 0, I. And then input 2 down to 0, S. We have 3 selection inputs, so 2 down to 0, output red, Y. So in our previous video, we have discussed the 4 class 1 marks where I have explained the Verilog code step by step. If you haven't watched it yet, please do check it out for a detailed understanding of the code since we already covered this type of Verilog code modeling. So for now, I will simply provide the code for the 8 cross 1 multiplexer. And then always the rate of asterisk begin case 3 tick B00 for S0, S1, S2 is equal to 0, 0, 0. I0 is transferred to the output Y. Similarly, I'm copying 0, 0, 1, 0, 1, 0, then 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, I1, I2, I3, I4, I5, I6, I7, and finally end case, end, end module. Yeah, with this our design code is done. Now let's move on to the test bench. Module TB. Here inputs as registers, outputs as wires. 7 down to 0. I input 2 down to 0. Wire Y. Now we need to instantiate our design module to the test module. So marks 8 cross 1. I comma S comma Y. Initial. Within this initial block we have to supply inputs. So here I am using repeat of 8 begin S comma I. Here I am using dollar random. So simulator itself will pick some random values and it will assign to it dollar random and providing some time delay for printing those values dollar display I is equal to percentage B, S is equal to percentage B, Y is equal to percentage B, I comma S comma Y, end, one more end and then end module. Yeah, that's it about the test bench. Now we need to select. Now let's run the code. Yeah, this is the final output of the 8 cross 1 multiplexer. And as you can see, the based on the selection input, based Based on the selection input, the corresponding input is transferred to the output y. In this case, the selection input is 4. Uh, Here, I of 4 value is 0, so that 0 is transferred to the output y. Yeah, that's it, guys. That's the working of an 8x1 multiplexer. Thank you so much for watching this video. Don't forget to like, share, and subscribe to the Digital VLSI channel for more interesting videos. Thank you.